Welcome to Chapter 1, the Database Environment and Development Process. In the course of Modern Database Management, and this slide is from Pearson Education. The book is from Jeffrey Hoffer, Ramesh, and Heike Topi. Let us get in this course together with the aim to learn in depth. The learning objectives for this course or this lecture for this hour are defining the terms, name limitations of conventional file processing, explain advantages of databases, identify costs and risks of databases, distinguishing between operational and informational data management, list components of database environment. I would strongly suggest you to take notes. You are welcome to pause this video and watch again, because this will allow you to take some decent understanding how we work in the database world. Identifying categories of database applications, explain prototyping and agile development approaches, explain the roles of individuals like role-based access control, domain-based access control, and all that. Explain differences between personal, multi-tiered, and enterprise data management. And last but not the least, explain three schema architectures: external, conceptual, and internal. So let's look into some definitions while we are starting in this journey together. The database is an organized collection of logically related data. The data is technically a stored representation of meaningful objects and events. The data can be structured or unstructured, structured in terms of numbers, text, dates, unstructured in terms of images, video, documentation. Information data processed to increase knowledge in the person using the data, and metadata is the data that describes the properties and context of user data. We also will look into organized data storage. That's where the databases help keep information neat and tidy. Imagine a library using the database to track all of its books. The librarians can easily find any book's location, check if it is available, and see who borrowed it the last. Databases make finding specific information fast. For instance, a hospital can use a database to quickly access a patient's medical history, allergies, and current medications when they come in for treatment. Databases also allow multiple users or people to work with the same information simultaneously. A retail company could use a database to manage inventory across different stores. When an item is sold in one location, staff at all stores can see the updated stock levels at the real time. So let's see what we have in this course for us to go and learn more. So this is a class roster, converting data to information, data in context. So I'm pausing here for a moment so you can look how metadata and data looks like. So customer data in an e-commerce is another example other than the class roster. So in an online retail context, customer data refers to information collected about individuals who interact with or purchase from the e-commerce platform, such as Amazon, such as eBay. This data typically includes personal details such as name, address, email, purchase history, browsing behavior, and references. For example, Amazon collects and stores vast amount of customer data that can be Target, by the way, or Home Depot, or Walmart, or Lowe's. They might record James Dinkle, living at 123 Main Street, has purchased 5 books in the last 3 months, frequently browses electronics, and tends to make purchases on weekends. This data is invaluable for personalized marketing, inventory management, and improving user experience. By analyzing this data, Amazon, Walmart, or some other, eBay, can recommend products to James Dinkle might like, forecast demand for certain items, and optimize their website to encourage weekend shopping. Another context can be healthcare or medical domain. Medical data encompasses all information related to a patient's health, treatments, and interactions with healthcare providers. This includes demographic information, medical history, test results, diagnosis, prescriptions, and treatment plans. For example, a hospital's database might contain a record of Jane Smith, a 45 years old female patient with type 2 diabetes. Her data would include her blood sugar levels, overtime, medications she's taking, and related conditions like high blood pressure, and notes from her doctor visits. This comprehensive data allows healthcare providers to make informed decisions about Jane's care, track her progress over time, and potentially identify patterns that could help her in treating other patients as well as her with similar conditions. It also facilitates continuity of care if Jane sees different specialists or changes healthcare providers. Hopefully, this is helpful for you. And we'll look into the summarizing data in a little bit. However, let me share with you another data in context that in the banking sector, financial data refers to all, and you can see this financial data here is 10% on the screen, the percent enrollment by major in terms of a class roster. But in a bank, so that we retrace, in the banking sector, financial data refers to all information related to the customers, accounts, transactions, and overall financial health. This includes account balances, transaction history, credit scores, loan information, and investment portfolios. For example, a bank's database might show that Michael Johnson has a checking account with an average daily balance of $5,000, a saving account with $20,000, a mortgage with $150,000 remaining, and make regular transfers to an investment account. The bank uses this data for multiple purposes to ensure accurate account management, detect fraudulent activities, assess creditworthiness for loans, and offer personalized financial products. If Michael applies for a new credit card, the bank can quickly analyze his financial data to determine his eligibility and appropriate credit limit. This data also helps the bank comply with regulations and generate required reports for auditors and regulators. So hopefully these examples make you comprehend how different types of data are collected, stored, and utilized in various contexts in improving the operations, decision making, and the customer service. So the roster of a student data would allow you to understand the number of students, the actual or the estimated, between 2013 to 2018. And that's since the book it has all that information available handy, so that allows you to learn more in this aspect of a class roster coming in at the university. Let's go through this in a little bit more depth. So summarizing data, before I go with the example metadata for class roster, as you have seen on the previous slide, let's take a few examples to understand why summarizing data is significantly important before we jump into metadata. So imagine a store that sells different types of products. At the end of each day, they have a long list of everything they sold. instead of going through this huge list item by item. They can use a database to quickly sum up their sales. That's one of the summary that comes in handy. However, how does that apply on a class roster? Let's look into that together. Let me share a little storyline here for you. Imagine a university called XYZU. It's a plane, it's a place full of eager students, dedicated professors, and hardworking staff. But running a university is not easy. There is so much going on all the time. That is where the magic of summarizing data comes in. Let me tell you how it helps in three different possible ways for a university to run the databases along with. And this will allow you to understand in the course roster aspect how it works. First, let's say there is a professor, Atif, the head of course planning. Every semester, Atif is swamped with questions: which classes are the most popular? Are there enough science courses, enough economics courses, enough architecture courses? Is the French department struggling to fill in the seats? For example, that's a good example. Instead of digging through mountains of paperwork, Professor Atif uses a clever database system. With just few clicks, professor can see summary of all courses. It tells him things like how many students are in each department, which classes are always full, and which ones might need a bit of a boost. This also helps the professor to make smart decisions about adding new classes or finding more teachers for the popular subjects. Then we have Miss Thompson, the student advisor. She is always looking out for students who might be struggling. But with thousands of students, it is hard to keep the track of everyone. This is where her data summary comes in handy. It shows her, Miss Thompson obviously, the average grades for each major, how many students are close to failing, and even how often students are attending classes. If she notices that, say, the chemistry majors seem to be having tough time lately, she can organize extra help sessions or talk to the department about making some changes. Finally, there's Mr. Johnson, who manages all the buildings on the campus. He needs to know how people are using the libraries, labs, and classrooms. Are some places always packed while others sit empty? His data summary, that's Mr. Johnson, gives him a bird's eye view of the whole campus. It shows him which places are busiest, when they are used the most, and how many people are using them. This helps him decide things like when to schedule maintenance, where they might need to build new spaces, or if they can use some rooms differently to help more students. All these summaries are like little helpers. They take all little details, every single student sign up, every grade, every time someone swipes their card to enter the building, and turn them into clear, useful information. It is like taking a big, complicated story and writing a short, simple summary that anyone understand quickly. This way, the people running this XYZU can make smart choices to help their students learn better, use their resources wisely, and keep the university running smoothly. And best part, they can do all this without getting lost in the sea of information. Hopefully, this storyline has given you some idea. Whereas the examples of metadata for the class roster, these are the description. Metadata is not the data per se. Instead, it is a description of how data is to be stored and organized in a database. Metadata enables database designers and users to understand what data exists, what the data means, and how to distinguish this data. So you can see there is a name, type, length, min, max, description, source. There's a course that is alphanumeric, length 30, course ID and name, academic unit, and the list goes on. Let's see what we have in the next slide for us to go through. Disadvantages of file processing. Let's look into this a little bit more depth. Now let's explore three examples of disadvantages of file processing, specifically focusing on program data dependence. I'll explain these in a storyline so you understand how it works. The first thing is the tale of stubborn inventory system. Let's take that as our title of the story. Imagine a small bookstore called Page Turner that uses an old file based system to keep track of their inventory. The system was created years ago by the programmers named Jack. One day, the store owner, Sarah, decides she wants to add a new piece of information to each book record, the book's weight. This would help her to calculate shipping cost over, the other side from Europe or from Asia or within the continental North America, the more accurate shipping cost. Excited about her idea, she asks her new IT person, let's say Emma, to make this change. Emma looks at the system and realizes she has a big problem. The program that manages the inventory is so tightly connected with the way the data is stored in files that adding this new piece of information is not simple at all. She would have to change not just the files, but also every single program that uses those files: inventory checker, the sales recorder, and report generator, and more. We should have been a simple additioning. It's technically what should have been a simple addition turns into a massive project. All because the program depended so heavily on how the data is structured in the files. Sarah is frustrated, and such a small change is causing so much trouble in terms of the expensive, add-ons. So another story can help you understand. A small family-run hotel or B&B called Sunset Inn that uses a file-based system to manage reservations. The system was set up by the owner's tech-savvy nephew Tom a few years back, let's say 10 years back. One day a guest calls to confirm his reservation, but the receptionist, Mary, can't find it in the system. She's sure she entered it last week. Confused and a bit panicked, she calls Tom for help. Then Tom digs into the system, discovers the issue. The program that enters the new reservation expects customer phone number to be exactly 10 digits long. When Mary entered the reservation, she entered the country code as well, making it 11 digits. The program silently rejected the entry without warning because it was so rigidly tied to the data format in the files. The program data dependence meant that simple variation in the data entry led to lost information and frustrated customer. Tom realizes they need more flexible system that can adapt to different data formats without losing such information. So hopefully this has given you a decent idea of program data dependence. I can tell you more in this. However, I would like you to go and find program data dependence in more depth. So that's pretty much going to be your learning. And let's move to duplication of data. That is, different systems, programs have separate copies of the same data. Limited data sharing, no centralized control of the data. That can be flat files, by the way. Lengthy development times. Programmers must design their own file formats. As the first example I shared with you, the development is needed on the old data sets in quite extensive basis. Excessive program maintenance, as you have heard in the B&B, 80% of the information systems budget goes on maintaining the thing. So means let's look at a small manufacturing company called GizmoWorks that uses a file-based system to track their production data. The system was built piece by piece over many years by different programmers. So, excessive program maintenance or lengthy development times is covered in this storyline. The company's manager, Robert, asks for a new report that shows the efficiency of each production line over the past year. Bob needs this for an important meeting with investors next week, for example. The current IT person, Maya, starts working on it but soon hits a wall. She realizes that the data needs to be for this report is spread across multiple files, each used by a different program. Worse, each program stores the formats of the data slightly differently. To create this report, Maya would need to modify several programs to extract the data in a consistent format, then writes a new program to combine and analyze it. It's a huge task that can be completed in time for Robert's meeting. This situation shows how program data dependence can make it extremely difficult to use existing data in new ways. The duplication of data is in existence, limited data sharing between different file formats, lengthy development times covered by this story, which I am just sharing with you. In all these discussions, we see how program data dependence in file processing systems can lead to inflexibility, data entry problems, and difficulties in data integration. These issues can cause frustration, lost business opportunities, and increased costs as excessive program maintenance mentioned on this slide. So let's see what we have next. Figure 1-2 or 1.2 old file processing system as at Pine Valley Furniture Company. I just discussed in my last storyline how this looks. So program A, B, and C works with the order filling system, customer master file, inventory master file, back order file. Accounting department has program A, program B, working with invoicing system, with inventory pricing file, customer master file, and payroll department has program A, program B, dealing with payroll system, employee master file, and all that jazz. So let's look into this together in more depth in upcoming slides. The database approach, data models, entities, and relationships. I would suggest you to read all these in more depth. Chapter 2 and 3 focus on data modeling. Specifically, we'll see and learn how to create entity relationship or ERD, entity relationship diagrams, or various types of entities, attributes, and relations. The ER diagram helps analysts to conceptualize and represent the real world environment, which then helps guide the database design process. And that database models or data models are graphical diagrams capturing nature and relationship of data. Enterprise data model, high level entities and relationships for organization, whereas project data model, more detailed view matching the data structure in database or data warehouse. Entities are nouns for describing a person, place, object, event, or concept. Composed of attributes, relationships between entities. It can be one to many or one to n, many to many, but also can be one to one as per our understanding. Comparison of enterprise and project level data models. Segment of an enterprise data model is customer, places an order, and for a product, so customer places order is placed by a customer. Order contains the product information or product is contained in an order. Whereas segment of a project data model has customer and product, whereas customer ID, customer name, places an order with an order ID, customer ID, and order date, and that contains the order line in terms of quantity and is for product, which has product ID and standard price whatever that allows you to understand how ERD works, or enterprise or entity relationship diagram. So the database approach has relational databases, database technology involving tables, relationships representing entities. The database management system is a software system that is used to create, maintain, and provide controlled access to the user databases. Most current DBMSs are in the form of relational databases, which represent data as collection of tables in which all data relationships are represented by common values in related tables. We will explore relational databases in detail throughout this course. Note that because all data is shared in a central database, there is no longer the need for separate systems and programs to maintain their own copy of the data. This includes duplication and increases integrity. So let's look into a little bit more in depth what relational databases are to understand in a storyline within a university. So let me explain relational databases and how a university computer science department might use them in simple terms so you can understand how database technology helps. Imagine a computer science department at a university, for example, CapTech. They have lots of information to keep track of: students, courses, professors, grades, and more, as I mentioned earlier. A relational database is like a super organized filing system for all this information. Here's how it works. Think of a relational database as a bunch of neat spreadsheets, like Excel sheets, all connected. One spreadsheet, we call it a table, has all the student information, another has all the course information, and so on. These spreadsheets are linked together in smart ways. Because everything is organized and connected, it is really easy to find information. If someone wants to know which students are in a particular class in terms of administration or the dean or the chair, or what grades the students got in all their classes, the database can tell you quickly. It also helps to avoid mistakes. For example, if a student's name is entered once, it is used everywhere. No more worrying about spelling it differently in different places. Now let's see how computer science department might use this. So they can use this managing students and courses. They can easily keep track of which students are taking which courses. When a new student joins or enrolls in a class, they just add this info to write spreadsheet or a table. The administration needs to plan for future classes. At the end of each term, they can quickly see which classes were popular and how students did in them. This helps them decide what classes to offer next time, helping students choose classes. When a student needs advice on what classes to take, the advisor can quickly look up what classes the students has already taken and how well they did in that. Keeping track of the research is another area where professors can use the databases to see what research other professors are conducting. This helps them to find people to work on their new projects or a system or collaborate. When administration needs to make reports like how many students passed certain class, they can get this information quickly instead of counting everything by the hand. The big advantage is and one of them is that all the information is at one place and it is easy to use. Before, they might have had to look through many different files or ask lots of people to get the same information. Now they can find what they need quickly and easily. It's like having a really smart assistant who knows everything about department and can answer questions in seconds. This saves time and helps everyone make better decisions because they all have good information easily available at their fingertips. So let's see what we have next. Advantages of database. Yes, technically there are many advantages, such as these are program data independence, not dependence. Plan, data redundancy, improved data consistency, improved data sharing, increase application development productivity, enforcement of standards, improve data quality, improve data accessibility and responsiveness, reduce program maintenance, improve decision support. As I'm sharing with you all these in terms of storylines, this allows you to understand how these databases work. The costs and risks of database approach. New specialized personnel are needed to work with these installation and management of cost, installation and management cost and complexity. Conversion costs need to for explicit backup and recovery. Organizational conflict can occur between different departments. So, integrated data management framework can be operational and informational, and let's look into that in a little bit more depth. I would strongly suggest you to look at chapters 2 and 3, 4, 5, 6, 7, 8, 9, and 10, and 11, and 12, as mentioned in this screen on the slide. However, I can share with you few exact use cases that I had a chance to work through in my industrial time or my industrial area of expertise. Imagine a big retail company, let's say Lowe's or Home Depot, has many stores and warehouses. They need to keep track of the stock all the time to make sure that they don't run out of products or have too much extra stock. An integrated data management framework, or IDMF, helps them to do this by connecting data from their sales systems, warehouses, and suppliers. It updates the stock levels in real time, automatically orders more stock when needed, and makes sure products are sent to the right places based on the sales trends. This way, the company can keep their customers happy by having products available, and they save money by not having too much extra stock at their hand. Another example could be, consider a manufacturing company that wants to fix their machines before they break down to avoid unexpected stops in production. And IDMF, or Integrated Data Management Framework, helps by collecting the data from sensors on the machines, past maintenance records, and even weather conditions. It uses the data to predict when the machine might break down and schedules maintenance ahead of time. This helps the company reduce time their maintenance or machines are not working and saves money on repairs. Another example can be customer's 360-degree view for marketing. A marketing department wants to understand their customers better to create personalized marketing strategies, and IDMF helps by combining data from different places like customer records, social media, customer service interactions, and purchase history. It creates a complete profile for each customer, which helps the marketing team creates targeting campaigns or targeted campaigns and measure how well they work. This way, the company can engage better with their customers and make them happier. Last not the least, fraud detection in insurance can be another big use case. I had a chance to work with such in one of my previous ventures. An insurance company wants to catch fake claims to avoid losing money, and IDMF helps by combining data from past claims, customer information, and external sources like police reports and weather data. It uses this data to find claims that look suspicious and need further investigation. There was not a storm or tornado, and the claim was filled in. This helps the insurance company to reduce losses from fraud, process claims more efficiently, and manage risks better. In each of these examples, the IDMF, or Integrated Data Management Framework, acts like a central system that brings together data from different sources. It helps the company make better decisions, both for day-to-day operations and understand the planning for their business. So now you understand the relationship between operational and informational arenas at how they intersect with each other in terms of technology, modeling, design, infrastructure, access, data analysis, governance, and data management all together in one go. So let's see what do we have in our next slide. The components of the database environment. Data modeling and design tools, automated tools used, uh, you know, for designing ERDs, repository centrals. So this is some sort of a dictionary that you can look into. Repository is centralized storehouse of metadata. DBMS is software for managing the database. Database is a storehouse of the data. Application programs are software using the data. User interface is technically UI, UX. User experience come with the user interface. Text, graphical displays, menus, etc. Data and database administrators use personnel responsible for maintaining the databases. System developers are personnel responsible for designing databases and software. End users, people who use the applications and databases. So this figure shows you the components of database environment. And let's see what we have in this. You can see that the UI is the central aspect, user interface. Data and database administrator look at UI, system developers look at UI, and users look at UI. Whereas UI is connected to data modeling and design tools. Those go back and forth between repositories, and user interface is directly associated to repository as well. DBMS is one of the use case, application programs, and the databases along with that help us understand in more depth as well. System development life cycle, prototyping. These are the areas which I suggest you to look very closely, because database management systems help in both SDLC and prototyping equally. The prototyping, where RAD is one of the things that is rapid application development, and the system development lifecycle, they contain a whole domains in themselves. So traditional SDLC comes from the days before advanced technologies made rapid application development possible. Prototyping and its variants such as Agile, Scrum, and Extreme Programming came about much later in the history of information technology. Many projects combine various elements from SDLC and prototyping. In next set of slides, we will look into steps in each of these approaches. So I would suggest you to read this. I give a pause, then I'll share with you a few examples. Planning, analysis, design, implementation, and maintenance. All right. Imagine you're building a new accounting software. First, you talk to accountants to understand what they need. Then you design how the software will work. Next, you write the code and to build it. After that, you test it to make sure it works correctly. Finally, you release it to the users and fix any problems that come later. That is called waterfall model in the arena of SDLC, or system development lifecycle. Another model is agile model. And in this case, imagine you're building a mobile app. You start with the basic version and release it quickly. Every 2 weeks, you plan new features, design them, write the code, test them, and release them. You constantly get feedback from users and make improvements in the next cycle. Last but not the least is a spiral model that we also look in the SDLC domain. And here you're building a critical software system for government agency. You start by planning the project, then look at for different things that could be wrong and plan how to handle them. Let me retrace a little bit more on spiral model. The spiral model is like a combination of step-by-step process and quick cycles. It focuses on finding and fixing problems early. The steps are planning, analyzing the risks, build and test, and review. In planning, we decide what we'll work on and as a next task and how we'll do about it or how I'll go about it. Analyzing risks looks at the things that could go wrong and plan how to handle them. Building and testing, it means writing the code and check for any problems, and reviewing, obviously look at how we have done and plan the next part or next potential task. So let me revisit the example that you're building a critical software system for governmental agency. You start by planning the project, then look for things that could go wrong and plan how to handle them. You build and test a small part of the system, review it and plan the next part. This cycle continues with each part building on previous one and reducing the risks along the way. Each of these models have its own way of doing things and is good for different types of projects. The waterfall model is simple and works well for straightforward projects, and the agile model is great for projects that need to be flexible and quick. The spiral model is good for complex projects that need careful planning to avoid problems. Hopefully this has given you a little bit more understanding in depth of an SDLC. And let's go to the next slide. This is our database development activities during an SDLC as mentioned earlier. Alternative information systems development approaches are traditional. SDLC has methodical, structured, and time-consuming. The traditional rapid application development, or RAD, is faster and more adaptive, especially when the database is already in place. Several flavors are prototyping, agile methodologies, extreme programming, Scrum, or DSDM, dynamic system development methodologies. The prototyping methodology and database development process has identifying a problem, developing initial prototype, implement and use the prototype, and if the prototype is sufficient, convert to operational systems. Otherwise, any problems that come, we revise and enhance the prototype by getting new requirements. The next version comes in, implement the user prototype. If it is sufficient, we convert it into an operational system. The three schema architecture, different people have different views. The term schema here refers to the view you have of the system being developed. Users of a system have one view based on the reports, forms, and interactions they have with the system. Designers have the view of the entities, attributes, and relationships involved in the world being modeled. The conceptual schema is an example, as well as the view of tables, fields, and primary and foreign keys, together with an understanding of what makes database well structured and efficient. The internal schema: if you are a database designer, you will be extensively involved in the logical and physical piece of internal conceptual schema. You will be particularly involved in the physical schema if you are a database administrator. If you are a user, these schemas don't matter much to you. Rather, you will be involved in the external schema, which can help you as an end user. Managing people involved in database development: the project, a planned undertaking of related activities to reach an objective that has a beginning and an end, initiated and planned and planning stage of SDLC, executed during analysis, design, and implementation, closed at the end of implementation. Project management is an important skill, and in any information system project, and managing the database design and implementation of tasks is part of project management. Projects often are organized into tasks and subtasks, each of which is scheduled for an expected time period and assigned to various people involved in the project. It is up to the project manager to monitor the progress and cost of the project associated. There are many different people, each of which has different perspectives, skills, and need involved in the system development project. Business analysts, the systems analysts database analysts, users, the customers, and the programmers are few of the examples as you can look into this slide. The database architects establish standards for data in the business units. Data administrators. The database administrator and data administrators are two different positions, by the way. Data administrators are responsible for existing databases, ensuring data integrity and consistency. Project managers oversee the projects, manage the personnel. Other technical experts, such as network administrators, operating system people, and documentation folks, are also necessary. The evolution of database systems driven by four main objectives. Need for program data independence, not data dependence, in order to the reduction of maintenance. Desire to manage more complex data types and structures, arrays of data access for less technical personnel, need for more powerful decision support platforms for someone to make informed decisions. The range of database technologies past and the present: 1960s, the flat files, 70s, hierarchical files, and between 17 and 80s, somewhere network files. Between 80 and 90s, relational files kicked in, and also 90s to 2000, object-oriented and object-relational files kicked in, whereas analytic data warehousing also started between 1980 to 2000, and analytics big data came into play between 2000 to 2010. You might have heard Hadoop, HBase, NoSQL, Hive, HiveQL, and all that jazz. So the range of the database technologies past and present, the hierarchical and network database models are the earliest attempts to structure data according to relationships between entities, but they fell short because they were very inflexible. For example, many-to-many relationships are impossible in hierarchical databases, and also although there are possibilities in network models, they are difficult to modify in these structures. So the relational model is the most ubiquitous and represent relationships as primary to foreign key associations in different relations. Here we see some confusing terminology. There is a concept of relationship which was shown as lines between boxes in the figure 1.3 as shown earlier, and there is another concept of relation which is really like a database table. We will see this distinction later in the semester while discussing in more depth. Object-oriented databases are interesting in that they allow for a sort of inheritance between classes and subclasses. Also, unlike relations or tables, in relation databases, objects in object-oriented databases are capable of behavior program code in the form of methods. If you take a course in Java or another object-oriented language, you will become familiar with these ideas in more depth. Multidimensional models are typically based on data warehouses and are used for decision support purposes. The star schema is a typical data warehouse structure. It is still in a relational database, but here are the two types of tables. Fact tables contain numerical data and can be aggregated. Prices, sales, revenue payments, dimensions are different lenses by which you can slice and dice the numerical data. Customers, departments, and products time periods. The terms online analytical programming or processing refers to the types of systems that they use that use multidimensional data. Big data is an emerging and concern and opportunity for business. This refers to the huge amount of unstructured data such as tweets, customer reviews, blogs, emails that are increasingly important for business decision making. And the V's, volume, velocity, and variety and veracity and value, are big buzzwords in the big data world. Even today, that is significant in the arena of large language models and NoSQL. The range of database applications: personal databases, typical size in the megabytes. uh, or gigabytes intended for one user. Departmental multi-tiered client-server databases, typical size in the gigabytes or even terabytes, intended for several users, usually does not exceed 100 departments wide. Enterprise application, typically the gigabytes, terabytes, or even petabytes, intended for very large users. The multi-tiered client-server database is to most web applications follow a three-tiered approach. Databases are typically at an enterprise tier, and application programs code is at an application web tier, and user interface for different users are at the client tier. The types of enterprise applications. Enterprise systems typically involve relational databases such as backbone of an organization, the ERP or enterprise resource planning, like SAP, you know, some other we have seen in terms of Microsoft, Great Plains Software, and all that jazz. Oracle has ERPs as well. Customer relationship management, supply chain management, human resources management, and payroll. Data warehouse typically involve relational databases, integrates data from multiple data sources, maintain historical data, help identify patterns and trends. Data lakes often don't involve relational databases. Large integrated repository for internal and external data that does not follow predefined schema. So, an example of an executive dashboard. This is Tableau software, and you can see that has sales by category, monthly performance, and mapping is also available. So this presents an example of what an output from a data warehouse might look like when a data warehouse can have several databases associated within. Pine Value Furniture is a fictional furniture company, will be used as a case throughout this book. Chapter 1 topics include database evolution at Pine Valley Furniture Company, project planning, analyzing database requirements, designing the database, using the database, administering the database, future of database at Pine Valley Furniture. And I can share with you something here that I have physically worked in a ball bearing manufacturing facility, how the database impacted them in helping maintaining the production going on. In the ball bearing manufacturing facility, as I mentioned earlier, keeping track of inventory is crucial. A database can help manage all the information about raw materials, finished products, and components in stock. For example, the database can store details like type of steel used, the quantity of bearings produced, and the location of each item in the warehouse. This helps the facility know exactly what they have, where it is, and when they need to order more supplies. It also ensures that production can run smoothly without unexpected shortages. The quality control is another area in the same manufacturing facility. Maintains high quality standards is the maintenance of high quality standards is essential for manufacturing ball bearings. A database can be used to track and analyze quality control data. For instance, the database can be recorded or can record the results of inspection tests and measurements for each batch of bearings produced. This information can help identify any defects or issues early in the production process. By analyzing this data, the facility can make improvements to their processes, reduce the number of defective products, and ensure that only high quality bearings are shipped to customers. Production tracking is another area in the ball bearing manufacturing facility. The efficient management of the production process is the key to meeting deadlines the customer demands. A database can be used to track every step of the manufacturing process from the receipt of raw materials to the final packaging of the ball bearing. For example, the database can log and start the end times for each production stage, the machines used, and workers involved. This information helps in scheduling production runs, balancing low workloads, and identifying any bottlenecks in the process. It also provides valuable insights into how to optimize the production for better efficiency and cost savings. In each of these use cases, the database serves a central repository of information that helps the ball bearings manufacturing facility operate more effectively. By using database, the facility can improve inventory management, ensure high quality products, and streamline the reproduction process. Hopefully, this lecture has given you ample to learn and move on with this lecture on the database management systems. This work is protected by the United States copyright laws and is provided solely for the use of instructors in teaching their courses. So I suggest you to keep it handy and for your individual use only. Happy learning. I'll see you in the next lecture.